we are going to take or solve some examples on sine rule, projection rule, and area of triangle by Hero's formula. We use half angle formulae, cosine rule, projection rule to solve the given examples. Now we are going to solve examples from exercise 3.2. Example number 3. In triangle ABC, if A is equal to 45 degree, B is equal to 60 degree, then find the ratio of each side. Okay, there measure of angle A is given, measure of angle B is given. We know that the sum of the angles of a triangle is 180 degree. Therefore, if we consider any triangle A, B, C, the sum of their angles, that is measure of angle A plus measure of angle B plus measure of angle C is 180 degree. We substitute the values of measure of angle A and measure of angle B, that is 45 degree plus measure of angle B, that is 60 degree, plus measure of angle C is as it is equal to 180 degree. Therefore, that is 45 plus 60 degree, that is 105 degree, plus measure of angle C is equal to 180 degree. Therefore, measure of angle C is equal to 180 degree minus 105, that is equal to 75 degree. Now we have the values of angle A, angle B and angle C. We calculate sine ratios for that. That sine A is equal to sine of 45 degree. We know that sine of 45 degree is 1 upon root 2. Then sine B, that is sine of 60 degree, that is equal to root 3 divided by 2, and sine C is equal to that sine of, here we calculate that measure of angle C is 75 degree. We substitute here, that is 75 degree. That is equal to, that we don't know that sine of 75 degree. Therefore, here we split that 75 degree as, that is sine of 45 degree plus 30 degree. We know the formula for sine of A plus B, that is sine A cos B plus cos A sin B. Therefore, here we write that is sine of 45 degree cos of 30 degree plus cos of 45 degree sine of 30 degree. We substitute the values of sine 45, cos 30, cos 45, sine 30. Therefore, here we get that is 1 upon root 2 into cos of 30 is root 3 divided by 2 plus cos of 45 is 1 upon root 2 and sine of 30 degree is 1 upon 2. That is equal to, here we get root 3 divided by 2 root 2 plus, that is 1 upon 2 root 2. That is equal to root 3 plus 1 divided by 2 root 2. Here we get the value of sine C is root 3 plus 1 divided by 2 root 2. By sine rule, we know that is A divided by sine A is equal to B divided by sine B is equal to C divided by sine C. We consider the two ratios only, that is A divided by sine A is equal to B divided by sine B. That will be written as A upon B is equal to sine A divided by sine B. And now we substitute the values. Therefore, that A upon B is sine A divided by sine B. We substitute the value sine A, that is 1 upon root 2 and the value of sin B is root 3 divided by 2. Therefore, that is equal to that 1 upon root 2 into 2 divided by root 3, that is equal to 2 divided by that root 2 into root 3, that is root of 6. Therefore, here we write A is to B is equal to 2 is to root 6. Now, we consider the second two other than these two ratios, that is B divided by sin B is equal to C divided by sin C. Now this can be also written as B divided by C is equal to sin B divided by sin C. Therefore, that B upon C is equal to, we know the value of sin B is root 3 divided by 2, and this divided by the value of sin C is root 3 plus 1 divided by 2 root 2. Here we write that is root 3 divided by 2. Reverse multiply, we make it reverse multiply, that 2 root 2 divided by root 3 plus 1. That 2 get cancelled. Here we get root 3 into root 2, that is root 6, and this divided by root 3 plus 1. Therefore, here we get B is to C is equal to root 6 is to root 3 plus 1. Therefore, here we have A is to B, that A is to B is equal to 2 is to root 6, and B is to C we have, that is root 6 is to root 3 plus 1. If we combine these two, we get A is to B is to C is equal to 2 is to root 6 is to root 3 plus 1. In that way, we have find the ratio of the sides of given triangle ABC. Now we are going to solve the next example, that is question number 4. In triangle ABC, prove that sin of B minus C upon 2 is equal to B minus C divided by A into cos of A upon 2. Okay, we know by sine rule that is A divided by sin A is equal to B divided by sin B is equal to C divided by sin C is equal to 2R. We consider all the separate ratios, therefore here we write A divided by sin A is equal to 2R. Similarly, B divided by sin B is equal to 2R, and C divided by sin C is equal to 2R. Therefore, here we get A is equal to 2R sin A, comma, B is equal to 2R sin B, and C is equal to 2R sin C. Now we consider the RHS of given equality, that RHS is equal to, that is B minus C divided by A into cos of A upon 2. That is equal to, here we substitute the values of B, C, A by using the sine rule, that B is equal to 2R sin B minus C is equal to 2R sin C, and this divided by, that is A, that is 2R sin A. And into cos of A upon 2 as it is, that is equal to, Now we take 2 are common from the numerator and cancel with the denominator. Here we get that is sin B minus sin C divided by sin A into cos of A upon 2. That is equal to, we use here the formula for sin A minus sin B. Therefore here we write that is in the numerator that is 2 cos of B plus C divided by 2 into sin of B minus C divided by 2, and this divided by that instead of sin A we write that is 2 times of sin of A upon 2 into cos of A upon 2, and that into cos of A upon 2 as it is. Here cos of A upon 2, cos of A upon 2 get cancelled. Here 2 get cancelled. Here remaining that is cos of B plus C divided by 2 into sin of B minus C divided by 2, and this divided by sin of A upon 2. That is, here cos of B plus C divided by 2 can be written as that is cos of pi by 2 minus A upon 2 into sin of B minus C divided by 2. This whole divided by sin of A upon 2 as it is. Because we know that in any triangle ABC, A plus B plus C is equal to 180 degree. Therefore, that B plus C is equal to 180 degree minus A. Therefore, that B plus C divided by 2 is equal to 90 minus A upon 2. Therefore, here if we apply the cos ratio on both sides, here we get cos of B plus C upon 2 is equal to cos of 90 minus pi by 2 A upon 2, and that cos of, now we know that cos of 90 minus theta is sin theta. Therefore here we now write sin of A upon 2. Therefore now cos of pi by 2 minus A upon 2, instead of cos of pi by 2 minus A upon 2, here we write that is sin of A upon 2 into that sin of B minus C divided by 2 as it is, and this divided by sin of A upon 2. Now that sin of A upon 2, sin of A upon 2 get cancelled. Here we get that is sin of B minus C divided by 2, and that is our LHS. Hence we proved. Now we are going to solve the next example with usual notation. Prove that A into, that is 2 into bracket A sin square C upon 2 plus C sin square A upon 2 is equal to A minus B plus C. Here we consider the LHS, that is 2 into, that is A sin square C upon 2 plus C sin square A upon 2. Now we multiply these 2 in the bracket. Here we get that is 2A sin square C upon 2 plus 2C sin square A upon 2. That is equal to that A into, here we write 2 sin square C upon 2, and here we write C into bracket 2 sin square A upon 2. And now this is equal to A into bracket, that 2 sin square theta by 2 is 1 minus cos theta. Therefore, here we write that 2 sin square c upon 2 is 1 minus cos c plus c into bracket that 2 sin square a upon 2, that is 1 minus cos a. That we know that is 1 minus cos theta is equal to 2 sin square theta upon 2. Okay, therefore that is a into bracket that 1 minus, by cosine rule here we substitute the value of cos c is a square plus b square minus c square divided by 2ab plus c into bracket that 1 minus the value of cos a is b square plus c square minus a square divided by 2bc. That is equal to a into bracket. Here we take cross product. Therefore, here we get 2ab minus a square. Because of minus sign, we change the signs of each term in that fraction. Therefore, here plus a square becomes minus a square. Now that plus b square minus becomes minus b square, and that minus c square becomes plus c square. And this divided by 2ab. Plus c into bracket. Here also we take cross product, and because of this minus sign we change the sign of each term. Therefore here that is 2bc minus, that is minus b square, that minus c square, and that minus a square becomes plus a square, and this whole divided by 2bc. Now here a get cancelled, here c get cancelled. Therefore here we get that is 2ab minus a square minus b square plus c square, this divided by 2b plus 2bc minus b square minus c square plus a square divided by 2b. Here both the denominators of these are same, therefore we take the addition of these two numerators, that is the 2ab minus a square minus b square plus c square plus 2bc minus b square minus c square plus a square, and this whole divided by 2b. That is equal to, now that minus c square plus c square get cancelled, here plus a square minus a square get cancelled, that is equal to, here remaining only, that is 2ab plus 2bc, that minus b square minus 2b square, this divided by 2b. Now we take 2b common from the numerator, that is 2b into bracket, here remaining a in the second term, here remaining plus c, and if we take 2b common from the last term, here remaining minus b, and this divided by 2b. That 2b get cancelled, here remaining, that is a plus c minus b, that is a minus b plus c, and that is our RHS. Hence we proved.